I listen to the Writer's Almanac every morning with Garrison Keillor, and it turns out today is the birthday of play critic Mark Connolly. It was very popular in the 1930s, but not with everybody. People used to abuse him a little bit. But having said that, he had something of a sharp wit. He was bald, and one guy approached him at a certain point and rubbed his head and said, "You know, your head feels just as soft as my wife's behind." And he reached up, Connolly reached up and felt his head, and he goes, "So it does, so it does." So, a little trivia for today. Well, let's get started. It is about 10 o'clock here on the West Coast. And what I would like to do is just to introduce my friend Bruce Severance, who has been in and around energy conservation, renewable energy, green product design and development, electric transportation, pretty much all his adult life. And as I recall, half of his younger life. Bruce, welcome.
Thank you.
So we're going to be talking a little bit about this today, and I'll just kind of flip through these slides. As always, what I would like people to do is simply to write in questions and just put them in the sidebar on the left. And Bruce, you can see the presentation online, right?
Yes, I can.
Good. All right. Well, so I'm just going to go through this and just let you talk. As a matter of fact, you know what? Rather than do that, we have a question to start with, believe it or not. Somebody wrote in something about an hour ago. And let me see if I can find that. I don't know whether you have any familiarity with this. We'll see. This gentleman writes, "I have a very intense interest in thermally efficient buildings and designed a house per Title 24 of the California Energy Code." I know you're familiar with that. My search for thermal efficiency led me to find new models for straw bale buildings, which I consider most efficient, low-cost, energy-efficient structures. This model has not been widely accepted by building code officials. Please have Bruce comment on the lack of this adoption. And there's a website to which people can go here. It's strawbalebuilders.wetpaint.com. But Bruce, do you speak straw bale?
A bit, yeah. I've actually participated in some straw bale workshops, and I would agree. I think that they are probably the lowest cost method of building a house with really high thermal efficiencies. There is a local builder in my area that's a real pioneer in this category. SEMS Company, SEMMES. You can see their website at semscode.com. And the owner of that company has been preaching the gospel of straw bale for at least 30 years. He's really a dynamic guy and talks a lot about it. Just about every new home that they build, they do a lot of custom homes, are passive solar straw bale houses, and they're fabulously designed. So you can certainly do something that is absolutely stunningly beautiful as well as thermally efficient with this type of construction. It's done kind of in combination with what's called, the new green framing techniques, where you're using 2x6 and post and beam structures with what are called strong walls to take the shear forces in the building, so that earthquake hits it laterally, it's not wanting to shimmy like a parallelogram. So when you're building straw bale, you have to build strength into concentrated locations in the building in order to allow for the positioning of the straw bales, to fill most of a wall, for example. So it has to be designed, with that structural integrity in mind. But it's a fantastic way to build, I believe.
Okay. Well, very good. So we have thanks for handling that. I think we got lucky there. I don't know how lucky we got, but I had no idea if you had any familiarity with that. So good going. So what's your purpose here?
I would, if I could just add to that, probably the number one decision that you can make as a designer if you're building a new building is, to orient the building properly to catch the amount of sun that you need relative to the temperature zone or the climate zone that you're in. And
So passive
straw
solar?
bale, pardon? Yes,
Passive
to take advantage of passive solar heating and natural wind, prevailing wind direction and that kind of thing. So, literally, 20 to 50% of the energy that the home consumes over its life is the result of the decision that's made in the first 2 minutes of design. So it's a very significant issue. And when you're thinking, as in a holistic way about designing the house as a system, you definitely want to take orientation into consideration, or all the thermal efficiencies that you put into the home are kind of washed by, the waste that's occurred by not paying attention to some of these other, significant and equally big issues.
Right. Well, very good. Let's go on. We have a ton of material here on this today, but before we do, let me just kind of go back and do some housekeeping on this thing. There are 2 ways of getting audio for this. Actually 3, if you include the fact that it's archived. It'll be archived on our webinars page on our website at 2 Green Energy. But the 2 ways of doing this live are through your speakers. I understand there are sometimes problems with respect to that. I've tried to do this as best I can. But if you're having trouble with that, just turn off the speakers and dial in at the audio, which you can see the number there and the code. I'll just leave that up another second if anybody wants to write it down. And then we'll just whip right into this. And Bruce, I happen to know that the next slide is about the purpose, which is largely of this presentation here today, which is largely about dispelling myths. You want to speak to that, and then I'll go right to this slide.
Well, I think the key purpose of this presentation is to analyze when you're considering, that most people these days don't have money to build the optimal passive solar structure, probably don't have the size of a lot required to make sure that they've got the sunshine on the sides of the house where they want it, et cetera. I think the issue we're faced with today is looking in this economy, what's affordable, what can people do that will contribute to efficiency and conservation, and what can we do that is the most cost effective. It's key because often people have misconceptions, and this is what I was talking about when dispelling myths. People often, the first thing that I hear from just about everybody I talk to is, oh yeah, my house is, definitely it leaks a lot, and I'm losing a lot of heat, and I need to replace all my windows. And it's the very first thing that people assume that they need to do to their house. And I'd say 99.9% of the time, it's not the primary issue, and it is, in fact, when you analyze the actual CO2 reductions or the energy savings that would result from investing in new windows on your entire house, it's at the very bottom of the list of priorities. If you're analyzing an order of how much bang for your buck you get on thermal efficiency, replacing the windows is not high on that list. It's quite low on that list, surprisingly. But it's because people tend to think about the things that are visible on their house, and they're not imagining where the heat's actually going. And the more typical problems are things that are relatively invisible and less obvious to people. So that's what the key focus of this is going to be, to help redirect people's attention where they can actually make significant energy savings at a much lower cost.
Okay, well, very good. I happen to know from looking at this that we get into some of the kind of personal philosophy. In other words, why is it incumbent on all of us to do any of this? So do you want to kind of walk us through here a little bit?
Sure. Well, I'm looking at the slide that says "Why be green" on it, and number one, although the greenhouse effect is an issue, the key thing here is to realize that when you're talking about home efficiency, it's not a matter of putting a bunch of money out that you never see come back to you. There's actually payback periods for different types of investment that you might make in your home. Some things have faster payback periods than others, and the real low-lying fruit we'll get into later. But people would be surprised that there can be easily a 10 to 17% return on investment. Some things actually pay for themselves almost immediately. CFLs, for example, if you're putting compact fluorescent light bulbs in your home, I think the figure is that if each lamp that you replace, each 100-watt lamp that you replace, is going to save you about $40 over the life of the bulb. Well, you can buy CFLs now for $3.50 or even as much as low as $1. I've seen them at Home Depot. They're quite inexpensive. So if every time you spend $1, you save 40. Well, that's a pretty good deal. I'd say of all the things, if you haven't already put CFLs everywhere in your home, that is absolutely key. There's a significant amount of energy that's saved for very little money. Let's move on to the next slide.
Yeah. So, here's what I was actually referring to. So, in other words, there's a personal economy issue, and then there's a kind of issue associated with sustainability of our planet and our civilization.
Yeah. Well, personal economy, I think, appeals to everybody. As far as the greenhouse effect is concerned, it's amazing to me that there's such a preponderance of evidence that the greenhouse effect is real, and science has demonstrated this, and yet there is still a great deal of skepticism and buzz created by that skepticism. You go online and you can Google climate change hoax, and there are large segments of our population in the United States that believe that climate change is just all false science, and for some reason somebody in the world is motivated to do this, and they attribute it sometimes to people who are trying to sell cap and trade, selling pollution credits and what have you. It's a big money scheme, and it's all those liberals trying to make money off of the conservatives. And to me, it's absurd. But there is, in fact, this significant portion of our society that is focused on, the right to pollute, as if it's a constitutional right, and they can do whatever they want. They want to drive their V8. They should be allowed to do that. If they need that, no problem. But they almost resent those of us that want to be more energy efficient. So I've put a couple of slides in here. I don't necessarily have to read this text, but the key thing is that there is, this preponderance of evidence. When we've analyzed, someone sat down and analyzed all of the peer-reviewed science published between the late 70s and the early 90s on climate change, and every document that had been peer-reviewed, every bit of scientific data that had been peer-reviewed, basically pointed to climate change happening. There's been some debate as to how soon it might happen, but not that it is happening.
Right. And you're absolutely right that there has been a shift in this. As a matter of fact, when I interviewed, my interview in my first book, Renewable Energy Facts and Fantasies, I think it's the third interview, is on climate change. And I was lucky enough to get the guy who was generally credited with discovering the phenomenon, who, this is Professor Ramanathan of Scripps, who in 1972 correctly predicted that there'd be a measurable increase in the temperature of the Earth's atmosphere by 1980. When I spoke with him 18 months ago, I said, correct me if I'm wrong, Doc, but has there not been a shift in public sentiment in this, at least in the United States? And he goes, yeah, pretty much exclusive to the United States. But you're right. Had we been having this discussion, 3 years ago, virtually every college-educated American would have said, we have a serious problem and we need to do something about it. And now this is kind of splitting across party lines as if it's some political football.
Well, we could theorize about why this phenomenon is happening in the United States, and I've got 2 or 3 theories on it. I can't say I know for sure why there is this segment of the population that is so determined to disbelieve the science. But this Pew Research study that's noted on this slide basically points to there being 1/3 of all Americans, believing that climate change is not real, and that's up from just a few years ago. In 2008, the same study found that only 21%. So we've how it is that we've gone backwards in this, and that people are increasing in numbers that in their disbelief that climate change is real, is to me an amazing phenomenon. And it says something about how important the public education piece of this is. It says something as to why it's so important that people in the general population have some understanding of what the hard science does say, that each of us reads a book about this and can speak with a little bit of authority to our neighbors about it. I have neighbors on my block that take this position, that they don't believe climate change is real, or they believe that there are certain segments. I'm a Christian myself, but there are segments of the Christian population that believe that because Jesus is coming back to save the planet anyways, none of it really matters. And I feel that that's kind of an insane point of view as a Christian to take, to disavow your responsibility for being a good steward of the planet. And I point out that prophecy doesn't make it right. I mean, the Bible prophesied that Judas Iscariot was going to betray Christ, and that didn't make it the right thing to do then either, So to me, it's kind of crazy that there's this leap of faith that comes into play. That's not all Christians at all. I'm very well connected to a multi-denominational, mostly Christian group of churches in my area, Central Coast Clergy for and Laity for Justice in the Central Coast, and have had direct contact with their executive director, and we've worked on some projects together, and they're very much engaged in promoting environmentalism and understanding of the greenhouse effect, and that it's a religious responsibility and a moral responsibility to be good stewards of the planet. So it is by no means all Christians either. It's just certain people kind of fall into this trap of believing that they can disavow responsibility, and that's okay.
Yeah, I'm with you. Let's move on. We've got a ton of material here.
Go ahead.
By the way, let me just jump in here for a second before we get into this, and talk and just say that just to put a period on this thing about global warming, I'm confronted by this thing all the time because I do these radio interviews at the rate of a couple a week. I always say, look, if you don't believe in this thing, that's fine. There are 6 or 8 other completely independent reasons to knock off our addiction to fossil fuels and to hit the accelerator with respect to efficiency. So, okay, let's get into this. I know there are a bunch of people here interested in a lot of this efficiency stuff. So I think there are a couple more slides on this subject. Why don't we just, this kind of speaks for itself. Maybe we could just hit this and head on. Do you have any brief comments?
And I think that most people that are probably in your audience are familiar with this, but obviously the U.S. has been the largest contributor to greenhouse gases, and Americans tend to have the most wasteful lifestyle. And of all the people on the planet, we're probably the ones that can cut our energy consumption most quickly and for the least cost. And we have, we have fat to trim is what I'm getting at here. Is we have ways of doing that maybe other cultures are not as prepared to do, and there's certainly low-lying fruit that we can take advantage of as citizens of North America, at least.
Yes, I'm with you all the way.
Okay.
So I know there's a couple of quick points on this thing, but just your point here in pointing out that you've got Hell and High Water and you've got Earth by Bill McKibben. In other words, the cost, if we're going to do something about it, now's the time to do it.
Yeah, I want to point people in particular to Hell and High Water by Joseph Romm. It's an excellent book that analyzes the economics of climate change mitigation and looks at several different scenarios and comes up with some hard data and hard numbers as to why it is better for everybody to mitigate climate change and greenhouse gas emissions sooner than later. It is definitely cheaper to do it in the near term than it is to put it off and wait until down the road.
Mm-hmm. And you're suggesting that there's some encouraging turns here.
Yeah, back in the early 90s, I was involved heavily with electric vehicle development, and I became kind of an industry spokesperson in Sacramento and worked as a lobbyist and showed up at all the zero-emission vehicle mandate hearings and had direct contact with oil industry lobbyists and, the head of the Western States Petroleum Association. I sat down to lunch with him several times and tried to convince him that diversifying into renewable energy would be good for the oil companies. And, it was a different world at that point in time. The oil companies were not prepared for that paradigm change. And happily, you can go to websites for Shell Oil and Chevron and find them saying some pretty progressive things. Now, perhaps they're only paying lip service to the greenhouse effect and their contribution to it. But the fact that they're publicly, taking this kind of position means that people are going to hold them to it at some point. And,
Yes.
They might surreptitiously be funding some propaganda campaign or creating studies that somehow oppose climate change. I don't know that that's happening, but I think it's a wonderful thing that they're, on their websites, they're acknowledging that they've been part of the problem and they want to be part of the solution. And I think it's a different world when that, companies with that kind of economic power have come to our side. They've come around.
I'm with you. Okay, so what you're saying here is that, okay, now let's just get into what can we do, and in particular with respect to energy efficiency. And I will put up your slide here. I hope this displays well. Is that legible fairly?
Yeah. I try to avoid getting into a lot of numbers, but sometimes it's necessary if you're trying to talk about the nuts and bolts of these things. But the key aspect of this slide is that if you look at what touches the common man on the street as far as what types of end use for energy consumption that people engage in on a daily basis, most people don't drive diesels or drive jets every day or fly every day. Most people drive passenger cars, and normally those are gasoline. Some are diesel, but normally we're talking about gasoline. And, transportation is 29% of the problem. Residential energy issues is 21%. Between those two, that's 50% of the U.S. energy consumed. The big category on residential is heating and air conditioning. And in water heating, air conditioning and water heating are actually quite equal as a national statistic. Of course, all these things vary according to region and really vary from one house to another, depending on the house. So, but the key thing is to realize the categories that you want to focus on are the ones that are going to make the most difference. And if you can switch to a more efficient mode of transportation, obviously that's huge. I've been driving an electric car every day for the last 5 years, and I can say that there's nothing that gives me greater sense of pleasure. I think the term used to be Fahrvergnügen, if you remember the old Volkswagen ads, and that's exactly how I feel about driving my electric car. It definitely gives me a sense that I'm being part of the solution by doing that. I still have a gas-powered vehicle that I use maybe once a month for longer trips, but it's good to look at what kinds of behavioral changes you can make and what kinds of purchase decision choices you can make that will have an impact. And not everybody can go out and spend $30,000 on an electric car, but next time you're buying a car, you can certainly be looking at something that's more fuel efficient than what you've been driving. And that's probably one of the biggest decisions that you can make to reduce greenhouse gases. And the next is looking at thermal losses on your home. And this is really the low-lying fruit. This is, there's a list of 10 or 15 things that are typically wrong with homes, and I can only guess that, for anybody listening, 8 of those 15 things are wrong in their own homes, and they have no idea that that's what the issue is. So we'll get on to focusing on that. This is basically, a slide where the statement that I'm making here is that it is always less expensive to change your day-to-day behavior as far as how you respond to a basic need. Instead of turning on the heat, putting on a sweater. Obviously, if you're willing to make those kinds of compromises, those kinds of behavioral changes are always the most cost-effective. So, from there we can get into where you actually increase. Those are considered conservation efforts. Efficiency really has to do with when you're changing the hardware and making the hardware run better in some way or another. As I said before, CFLs are really the low-lying fruit. You're going to save 34 pounds of CO2 per year with every 100-watt light bulb that you replace. You're going to save $40 over the life of the bulb. If you've got your house full of incandescents, it does not make sense in this category to wait till all your incandescents burn out before you replace them. You should just go buy a box of CFLs and replace them all. That's not true necessarily of buying a new furnace, for example. Sometimes it makes more sense to wait till the old furnace goes out in terms of the economics than it does to just buy a new one. It really depends, again, on the condition of that furnace. And, it might be working, but if it's really an energy hog, then it does make sense to just replace it before it breaks. This is kind of the key thing that most people have no idea is going on, and it is extremely important. If there's one piece of information you walk away from in this webinar, it's that duct tape does not work, and it has been catastrophically failing in heater systems all over the country, and people have not noticed it because these ducts are normally wrapped with insulation. And Lawrence Berkeley Laboratory recently conducted studies on this, and there's all kinds of research that you can easily access online that verify this independently. But the average American household is losing 30% of the heat that's generated by the furnace by pumping it directly out of the house before it even reaches the registers in your bedroom. And the photo you see here, these are typical things that you see when you unwrap the ducting. You take the fiberglass off the ducting, you start to see where the failures are, and duct tape does not stick. It doesn't like the temperature variations that it sees in this application, and it doesn't work. So there are much better products out there. Typically, homes that are built in the last 3 or 4 years probably do not have this problem. There's better products available that have been in use for the last few years, but anything built from, let's say, 2006 and before, you most likely have this problem, and you should not wait 5 years to replace your duct tape. You should just replace it. It would take all day on a Saturday to do it yourself. It's not that hard, and there's enormous energy savings from doing this. Air sealing is kind of the second category. The most typical places where air leaks is underneath your tub. Generally, there's an access hole that often plumbers do not cover over. You can just buy 1-inch styrene foam at Home Depot and cut it in a square and get some fender washers and screws and screw it on over this. You don't want to glue something up here because you need access to this in case something happens to this hardware. But the hole that you see in the photo on the right is typical, where there's places under the house or in the walls where air is coming into the wall, and you want to avoid air getting into the wall cavities within the house. Another thing you see typically in older homes and some newer homes is the photo on the left is where a wall cavity is open to an attic space, and this is taken kneeling down, looking down into a hole. And what happens here is you throw a piece of insulation over that, and really the insulation doesn't do any good. Insulation is not an air barrier, does not prevent cold air from going into this hole. Any kind of little half-inch or quarter-inch gaps around the insulation basically invalidate that piece of insulation anyways. But you want to take a piece of plywood and, clean this up and put some caulking down and screw something down so it's completely airtight and seal off that cavity. You see that kind of thing often above built-in cabinets in newer homes as well. And the other big category is plumbing penetrations and electrical penetrations where plumbing and wire go through the top plate and bottom plate of a house. So that would be the horizontal 2x4 stud at the bottom and top of a wall where a hole's been drilled and maybe the hole's half inch or an inch bigger than the plumbing pipe that goes through it, and there's a big air gap there. So the cold air comes down into the house and comes out of light fixtures and switch plates and things like that. Insulation is key. I'm giving you a summary here of what's typical in homes in the U.S. Anything built before 1960 basically has no insulation in it at all. Between 1960 and 1978, you have a little bit of insulation in the attic. Anything that old, insulation is probably in such poor condition it wouldn't hurt to just replace it entirely. And the newer homes have R13 in the walls and R19 in the attic. It does not make sense to try to increase the R value in the walls in homes that are built after 1978. Generally, what we do is add to the insulation in the attic space or in the crawl space underneath the floor, and that's what makes the most sense. But before you insulate, you want to make sure you do a really good job of sealing all the joints at the tops of walls between the drywall and the stud wall. There's gaps where a lot of heat escapes right at the corners of the room. And you want to take a caulking gun up there and kind of peel back the insulation, seal all the plumbing penetrations, and caulk between the drywall and the 2x4 top plate of the wall. And that really does a tremendous job at slowing down the thermal losses in the home. And these are things that any homeowner could actually do themselves, taking proper safety precautions to not step through the drywall ceiling. Obviously, you're up in the attic. A lot of people don't realize it's not a structural thing. It's just as good as having nothing underneath you, and you can fall through drywall. So you want to move a piece of plywood around and get up there in a way that is not a hazard to you. And be sure to wear a particle mask and things like that. Don't be ingesting, the suspended particles that you're going to find in an attic are quite unhealthy. Building Performance Institute is an organization that's based in New York that's nationally recognized to set standards for certification of contractors that are involved in building performance auditing and energy upgrades. And you can find them, I think, at bpi.org on the internet. What they do is offer credibility to this business, and they set standards for the kind of test data and test procedures, as well as things like the amount of fresh air that should be going through the building. These things are also touched on by other organizations like the contractors organizations that govern, plumbing and HVAC, heating, ventilation, air conditioning, what have you. But BPI is the only organization that's nationally recognized to set standards for this energy upgrade industry on the whole.
So what you're saying, Bruce, is that if you do too good a job with air sealing, you wind up with too few air changes. You need about 3 an hour. Is that what that's saying? Oh, no, you need one every 3 hours.
That's correct. Yeah, you exactly. You want a full exchange of the air in the house at least once every 3 hours. That's 0.35 air changes per hour is the standard. It's not 0.333. But I've heard this debated in terms of what's actually healthy. This just happens to be what the national standard is. There are those engineers that argue that you could have less than that, and it also depends on the number of occupants in the house, and there are calculations that go into it. So it's a little bit more complicated than this slide might indicate. But BPI actually sets standards that are based both on interior air volume and the number of occupants in the home. And it is very important, if you're doing all this sealing of your home, to be sure that you have methods for ventilating the home properly, and that you don't have moisture buildup in the crawl space, for example, that now that you've tightened up the house, the moisture is accumulating, it's not evaporating, and you're setting in motion a set of circumstances where mold might begin to grow because you've sealed too much, but you haven't looked at the ventilation portion of this. So, there's other, aspects that are related to this that you definitely want to pay attention to as a consumer. And this is why you want a BPI contractor involved to help you test the house for leakage, and they can also tell you exactly where your leakage is happening. There's infrared camera imaging that they can do, BPI auditors can do, that will show you where you have the most thermal losses, and it kind of helps direct you at where you need to spend your money to tighten up the house and how much ventilation you might need. And it might be as simple as replacing a bathroom ventilator fan with, there's a type of bathroom fan ventilation that Panasonic makes now that brings air in at the same time that it pumps it out, so you're not depressurizing the house. And it puts that air through a heat exchanger. So the outgoing air, which is warm, is preheating the air that's coming in, and you're not losing all the heat in the interior space by just pumping the air out, as most ventilation systems do. So those are fairly inexpensive now. You can buy that type of a bathroom vent that I think pushes about 70 cubic feet per minute for around $300. They're not really expensive. They're fairly inexpensive.
Okay. All right, so we have a couple slides here with some numbers. You want to just hit the highlights?
Yeah. This is, I wanted to refer people to this because it's a fairly interesting study, and it's, I think, objective, where they've analyzed homes, the typical, home from different eras, different decades, relative to different types of energy upgrades. So the package 1, package 2, package 3 that you see in this chart refers to different types of energy upgrades that can be done. And then the climate zone is abbreviated as climate zone 4 and climate zone 5, and these are both fairly moderate climate zones. There are 16 climate zones in California, so these are just 2 of the 16 climate zones in California. The climate zone 5 is a moderate temperature coastal climate near San Luis Obispo. That's where the study was conducted. Climate zone 4 is inland a bit and has broader temperature swings. It's colder in the winter, it's hotter in the summer. So it's analyzing the cash flows relative to energy savings from doing different types of energy upgrades. And this is kind of the summary of that study. And to really make sense out of this chart, you'd have to read the study. So I'm putting this in here for reference only and not expecting anybody to be able to look at this chart and identify exactly what it means. But the study, if you're interested, is very much worth reading. You can download it from slowgreenbuild.org online. And it basically says, look, here's some different climate zones. Here's houses built across different decades. And in virtually every case, the amount of money that you'd have to pay on a monthly basis goes down by doing these energy upgrades. So if
right, I think that's the takeaway I would leave listeners with. In other words, you have a positive cash impact after financing costs, regardless of which package, which climate zone.
Exactly. So I mean, this is solid evidence that this makes sense to do, and there really is not a valid argument of, oh well, I'm going to have to wait till I got a little bit more money. These are actually fairly easy loans to qualify for, and they vary regionally, even by county. So I can't speak about the specific loan packages, but go talk to your banker and find out what kind of energy efficiency upgrade loans are available in your area, and you'll find that there are some, and it makes sense to do this. You should not wait until you've saved $10,000 to go do all these energy upgrades. You should figure out a plan and put it in motion.
Yes, and this is just, I probably should have put this one up first, because this is just a little bit of information as to what do we mean by these packages.
Yeah, I think if you flip to the next slide, there's some background that there's a couple of slides. Oh, I'm sorry, you already have. These other slides kind of support that first slide, which is kind of the summary of the bottom line of that you get bang for your buck. And then these other slides kind of help explain, the percentage of energy savings relative to the age of the home, and what some of the assumptions were that went into the study. But really, to make sense of all this is just trying to summarize something that's in a 25 or 30-page document. It's worthwhile to read the study, and anybody that has their doubts would be convinced that this is something that makes sense for them to do, and not wait until 10 years down the road.
Very good. If anybody wants to write me, I will make sure I'll send out a link to that study that Bruce is referencing there.
Yeah, and I think I'm sure Slow Greenbuild wouldn't mind if you just had a copy of the study that you could download from your website if you wanted to handle it that way, and we can arrange that at a later time. The thing I wanted to get to is that what we actually see in practice in the field. I mean, you can analyze these numbers and do energy modeling of typical houses and come up with cash flow scenarios, and the study is based on financial analysis and thermal loss projections and things that are actually quite well modeled. But in reality, we find these things to be true as well, and that's where there are actual savings in practice. So even though that study is full of projections and energy modeling and what have you, in reality, this stuff works. We've seen energy upgrades where people maybe spend between $5,000 and $8,000, and because of what is wrong with their particular house, the cost of the improvements are relatively affordable and easily done, and they have a 50% reduction in their energy consumption without changing their behavior. And so the point is here that it doesn't really cost that much money, and if you were willing to do the work yourself and learn what you need to learn to do it yourself, it's really not that difficult to do it yourself. A lot of people don't want to crawl around in their attic and get dusty, and it's not comfortable kind of work to do, but it's certainly not impossible to do it yourself either. It's really not that difficult. So there are real savings benefits, and the key thing here is that it really does vary from house to house, and every house has kind of its unique problems and unique circumstances, and it is impossible to say, speak in generalities where you say, yeah, everybody that spends $5,000 is going to cut their energy costs in half. It isn't the case. I'd say on average, somebody that spends $5,000 probably cuts their energy costs by 20 or 25%. But a lot of people have problems that are easy to fix, and there's significant savings, and it varies from house to house.
And I guess you're about
energy upgrades. I don't know how much of your audience is California-based, but in California, I just need to mention in passing that Energy Upgrade California is a program that covers up to 40% of the home energy improvements that you want to do. You have to have a BPI contractor involved, and the first thing that they do is check combustion appliances for things like carbon monoxide in the home. You don't want to tighten up a house that's got carbon monoxide issues, obviously. If it was breathing more before and suddenly you've sealed it up tight and you've got carbon monoxide, that's not a good combination of events. So BPI is, preaches this gospel about safety first, and BPI contractors are very familiar with combustion appliances and how they should be configured. So it's extremely beneficial to have somebody like this involved in your project either way. But if you get 40% energy improvement in your home, they'll give you $4,000 toward that. So, if the whole project only cost you $5 to begin with, you could end up with some significant home improvements and lower energy bills with very little cost involved, and the payback would be quite fast. So it's an excellent thing to look at, and this program is only supposed to go through 2012 or so.
Okay. Well, maybe, we'll hope it gets renewed. The book I'm coming out with in January is Renewable Still Doable. Includes a set of interviews with folks. Largely, it gets into the economics of this issue. In other words, if this is such a hot idea, why are we doing such a terrible job at it? And the guy I interviewed who's a consultant to the Obama administration in doling out ARPA-E money, pointed out that energy efficiency is actually a far easier, slam dunk issue than renewables, and especially in terms of not scaring off investors. In other words, this uses extremely common, proven technology, and it puts a ton of people back to work. In terms of job creation, energy efficiency is really a wonderful thing. So hopefully,
it is, and I've been analyzing energy issues for 25 years now, and I could say with some confidence that home energy improvements are distinctly the least expensive thing that you can do. And if you're hoping to eventually be net zero and have a zero carbon footprint, and that's your goal, and you want to add solar and maybe solar thermal to your home eventually, it certainly makes economic sense to do these other energy efficiency upgrades first. If you've got an energy hog refrigerator that's more than 10 years old, you shouldn't wait to replace that. It actually has a pretty good payback to replace that appliance sooner than later. It's probably consuming more energy than you imagine. And you'd want to do that before you put solar panels on the roof of your house anyways. The cost of your solar system might be twice as much if you don't do those energy efficiency upgrades first. So instead of spending, $25,000 on solar panels, you spend $4,000 or $5,000 on energy upgrades, and you only spend $15,000 on a solar system. So there's a net savings by doing the conservation, even if you want to do solar eventually. It makes sense.
Yep, exactly. And John Robbins, who's a frequent commenter at Two Green Energy, says, in early days, efficiency upgrades and conservation were always done before renewable energy. Yes, indeed. John, thank you. All right, let's go on. You've got an opinion here.
Yeah, well, this is opinion, but my opinion is that the American dream is something that's been idealized, for the last century and a half, and we tend to cling to this ideal of, driving a nice car and having a big house, and people want 3,000 square foot houses, and we just went through this building boom in the last, 15 years that ended in a crescendo in 2008. And a lot of the houses that were being built during that time period were not necessarily that efficient, and a lot of the efficiency, in my mind, is in how people use their space. It doesn't really make sense to have a 3,000 square foot family if you're, two adults living in a house, and the reality is the kids are going to go off to college at some point, and then you're still sitting in that house. And there are a lot of people in our country that have two adults living in a 3,000 or 4,000 square foot house. It just doesn't make sense, really. So my opinion is that the American dream instead of being focused on conspicuous consumption, needs to be focused on conspicuous conservation. We really need to be thinking about doing what's right by the planet and scaling our dreams accordingly. And there's really nothing wrong with, a 1,500 to 1,800 square foot house, making good use of the space. And it makes sense to make those kinds of compromises with what we want out of our lives. And if we love our children, it's appropriate to think about, minimizing what we expect or insist on out of life.
Yeah, I completely agree, and this comes up constantly. Not only is it a good decision to make at a personal level, but it really does have something to do with, caring for one another and for the quality of life that we're leaving for our children. And it's funny because I get into these debates with people all the time. There are a lot of, you probably come across the fact that there are a bunch of naysayers on electric vehicles, that only tree huggers are going to buy these, and they've already bought them, and now this thing is a dismal failure, which I think is a completely fallacious way of analyzing what's happening. It is true that green has not yet become cool, but I think there's a scenario under which that's exactly what happens. In other words, that there's a kind of raising of consciousness, and all of a sudden it's cool to do this. Instead, it's not cool to live in a house or to drive a Hummer or to live in a house that's 3 times as large as you need. And I think I'm already seeing the signs of this moving in this direction. And I point out that movements like this in society are not unprecedented. When I was a little boy, forgive me if you heard this story before, but when I was a little boy, it was fashionable for my mother and her friends to go out to dinner wearing mink coats. This was the early 60s. Well, a couple years later, you couldn't find a mink coat. Everybody had gotten the message that anybody stupid enough and selfish enough and brutal enough to wear mink was rightfully regarded as a Cruella de Vil. And it happened really quick. So, and I'm wondering if there isn't a trajectory under which that's exactly what happens here in our world today.
Well, now you've opened the subject up. The answer is yes, it most definitely is happening. I read something recently, and I can't remember the source, I apologize, about the Toyota Prius, or some market research that was done on it after it was out, and why people preferred the Toyota Prius over other hybrids. And there seemed to be this connection to the Prius because it was so distinct looking, and from a distance people could instantly recognize it from a block or 2 blocks away. If you were driving a Toyota Camry, you really couldn't tell from a block or 2 blocks away that it was a hybrid electric vehicle. So the idea is that there's a certain market of people that do like conspicuous conservation. They want to be recognized for doing the right thing, and appropriately so. So in my mind, I think the market crossed a threshold about 1990 where for the first time, over 50% of the market polled said that they would pay a slight premium for something that had environmental benefits. And that was a U.S. poll. I don't recall who did it, but I recall when that happened. It was the first time in American history that more than half of the population said they would pay slightly more for something that was a little greener. And I think that that trend has continued in large part, except for the backlash that we see among the climate hoax advocates, and those that seem to cling to their constitutional right to waste energy if they want to, and to not be overregulated. I personally embrace Title 24. I think it's a pretty decent law, and it's headed in the right direction, and it's sufficiently flexible to let people do what they want. And if you've got west-facing views, you can put in more windows. You just have to make up for the energy losses someplace else in the house. So that it's compromising enough to allow people to do what they want to do.
And Title 24 is California's building code, essentially?
It's the energy efficiency portion of the building code.
Okay.
It also encompasses the American Disabilities Act regulations, but it's best known, I think, for the energy efficiency component.
Okay. Here's a question from the audience. Certified energy management training programs advise the use of NPV, net present value, I guess, to calculate payback on energy projects. Why are you using ROI to gauge payback?
Well, it's because I feel like it's the language that people are most used to, and I feel it's what speaks to the audiences that I've spoken to in the past. So, talking in terms of simple return on investment, people kind of go, "Oh, return on investment." They can relate to it. They've had to make purchase decisions before where that's what that was the paradigm or the framework that they were thinking about. Obviously, return on investment isn't really the only paradigm through which to analyze these things, and there are often a lot more variables than might show up in these slides. For example, a big variable is projected increases in cost of energy, and so if you start looking at the real return on investment is probably faster because energy costs have gone up at a certain rate over the last 30 years, and it's not likely that they're going to continue going up at that same rate over the next 30 years. It's likely to go up at a much faster rate. So, if I tried to guess at all those things, I'd come up with something that wasn't conservative enough. And so these figures are really based on, I'm trying to be as conservative and middle of the road about making a projection when I make it. And I have to add that it's a projection, so you take it with a grain of salt and understand that it's based on a whole set of assumptions that may not be clear in the slide that's in front of you. So I'd be the first to admit, any analysis like this is full of assumptions that really need to be qualified.
Okay. Well, very good. Here's another question. How can we make more, this is maybe a kind of rhetorical question because I'm not sure there is an answer, but it's a good one anyway. How can we make more visible and obvious how much energy we use per person? Simply having an a hybrid electric vehicle doesn't say how much fuel is being used per person per year. I favor telling people how much, like 200 gallons per driver per year. This is 60% less than average. But how do we do this in a house? Question.
Well, that's an interesting question. I've actually had some brainstorms, and one thought that I've been involved with Slow Green Build in San Luis, and one thought I had lunch with the president of that organization a couple of weeks back, and we were brainstorming doing something that would be kind of a green shield or an emblem that you could make as a sign that sticks in the lawn in the front of the house, and if you achieve, a 20% reduction through efficiency, it would say that. If you achieve another 20% reduction through conservation and behavioral changes, you could put that on the sign. I think that people kind of want to hang their medals and take credit for the conservation efforts that they're putting into their lifestyle changes. And I think that it acts to educate the neighbors about what they're doing and say, hey, I didn't know this is possible. It's going to promote discussion of the issue and get people to log on the websites to get more information and that kind of thing. So we're talking about ways to do that. And I think it's beneficial to facilitate dialogue in that manner.
Well, fantastic. Bruce, this has been terrific, as I knew it would be. Thanks very much for joining me here this morning, and thanks for the audience all over the world for joining. Anybody who wants to pass this a kind of archived version of this along to a friend is welcome to do so. It'll be up on the website in a day or so. Bruce, again, thanks very much, man. Nice to talk to you.
All right. Take care, Craig.
Okay. Bye now.
Bye-bye.